AI is starting to look less like a text model and more like a control stack. This week's most interesting shift is that systems are getting better at turning a single observation and a single instruction into action, whether that means grasping the right object, tracing the right motion, or navigating by latent semantic structure. The bigger trend is simple. We're moving from prompt following to grounded, reusable interfaces for embodied intelligence. Keep watching, because the details here tell you where robot autonomy is actually becoming practical. Let's explore the first paper, AFUN towards an affordance foundation model for functionality understanding. AFUN is a step toward an affordance foundation model for functionality understanding, built on a standardized pipeline that converts heterogeneous robot, human, simulation, and real-world scan data into a shared RGBD, language, mask, and 3D motion schema. The model uses a frozen Qwen 3, VL, 8B vision language model, SAM3, and a Sonata 3D encoder connected through metaquery tokens to jointly predict a task-conditional functional mask and a post-contact 3D Bezier spline curve from one observation and one instruction. The data pipeline starts from 321,190 raw videos across 10 public sources, expands to 1,242,740 action intervals, and after filtering retains 223,334 motion-labeled samples, with 59,867 training samples used for AFUN. On affordance segmentation, AFUN evaluates on 8 test sets from 4 benchmarks and reaches 69.3 mean GIOU and 67.2 mean CIOU, improving mean GIOU, CIOU by plus 23.9, plus 26.3 over the strongest baseline. For contact point prediction, using the pole of inaccessibility of the predicted mask, AFUN improves hit rate by 12.7, 61.3% over prior methods. On 3D motion, it achieves the best ADE, FDE, and contact and mask hit rate on all 3 test sets, including 0, 98, over 0, 100, and 39, absolute ADE, FDE, and 81% CIM on the AFUN test set. The system also transfers to real robot manipulation with a Franca Research 3-arm, achieving a 90% average success rate across 4 tasks without embodiment-specific fine-tuning. Let's explore the second paper, Guava, an effective and universal harness for embodied manipulation. Guava is a harness framework for embodied manipulation developed by researchers from the University of Maryland, the University of Illinois Urbana-Champaign, the University of Waterloo, MBZUAI, the University of Pennsylvania, and Amazon FAR, that asks a practical question. What interaction design lets a vision language model act as a robust robot controller without end-to-end action prediction? The paper's answer is a React-style closed loop that interleaves perception, reasoning, and tool use, paired with semantic action abstractions such as grasp, object, align object, direction, clearance, and get, position object, plus multimodal observations that combine images with compact state text. In ablations on 6 long-horizon RoboSuite tasks, this design outperforms single-turn and low-level interfaces and is instantiated with GPT-5-4 to validate the harness itself. The authors then distill the behavior into Guava, Agent 4B, built on Qwen 3, 5-4B, using fewer than 2K trajectories collected entirely in simulation. The final dataset contains 1,934 trajectories across 237 prompts, with 1,191 successful executions and 743 recovery trajectories. With this setup, Guava, Agent 4B reaches 75.6% overall success in simulation, beating GPT-5-4 at 70.2% and CAP, Agent 0, at 62.7%, and transfers zero-shot to a Franca Research 3 robot with 86% ID and 92% OOD success. Targeted GRPO on the hardest long-horizon tasks lifts shell game from 6.7% to 60%, and place all red objects in basket from 0% to 93.3%, showing that the harness plus compact post-training can produce emergent failure recovery and strong sim-to-real generalization. Let's explore the third paper, Platonic Nav Unveiling Semantic Correspondence in Navigation with Platonic topological maps. Platonic nav argues that vision-only object goal navigation, cross-modal object goal navigation, and vision language navigation are three interfaces to the same object-centric semantic manifold, and it turns that claim into a training-free navigation system built on the Platonic representation hypothesis. The key move is a Platonic topological map that fuses geometric 3D edge cost with a semantic Platonic distance, computed from a self-supervised visual encoder, then grounds language goals by blind matching between independently pre-trained Dynov3 and GTR T5 embeddings without paired vision language data, contrastive pre-training, or VLM supervision. On HM3D, IIN, the map raises SPL from 59.1 to 62.6 and SSPL from 64.6 to 70.8 over Object React. On HM3D, OVON, it reaches 51.8 steradians and 23.8 SPL on Valsine, 49.8 steradians and 23.1 SPL on Valsine synonyms, and 48.7 steradians and 22 SPL on Val unseen, outperforming most cross-modal baselines. On R2R, CE Val unseen, it achieves 63.5 steradians and 40.4 SPL, remaining competitive with several VLN methods. A real-world deployment on a Unitree Go 2-Air quadruped further shows the framework can run in RGB-only teach and repeat mode, suggesting that semantic alignment is already latent in independently trained vision and language representations. That's a wrap on today's AI paper highlights. Thanks for watching.